Hi there again, everybody. Last time we talked about whether arithmetic series or geometric series actually had sums, infinite series, whether they actually had sums or not. We figured out that arithmetic series never had a sum. Geometric did sometimes. If the common ratio was between -1 and 1, then it did have a sum, and this was the formula for it. If the absolute value of the common ratio was equal to 1 or bigger than 1, then it did not have a sum. But what if it's not? What if a series is not arithmetic? It's not geometric either. Well, then what do we do? We're going to start talking about that today. Here's one piece of the puzzle. And we can kind of think about this. If you add a number each time that does not get closer and closer to 0, say we add a number that gets closer and closer to 1 every time, that series is not going to have a sum because you're going to continually add numbers that are getting close to 1. I mean, even if you added 1 each time, if you keep adding 1, like say you start with 4, and you add 1, that's 5, add another one, that's 6, another one, that's 7, another one, that's 8. If you do that an infinite number of times, the sum is just getting bigger and bigger and bigger by 1 each time. It's not going to get closer to anything. So the number that you add has to be getting closer and closer to 0. If it gets closer and closer to anything else, there is no sum. And that's the one test we're going to talk about today. AN is kind of the general term. It's that formula we use to find the nth term in a sequence or a series. If the limit as n goes to infinity of that isn't 0, then there's no sum. Now, if it is 0, there might be a sum, there might not. We'll talk more about that situation at a later date. But for now, if it doesn't equal 0, there's no sum. That's all the farther we can go. So the first thing we need to do is write an equation for AN. We had formulas for arithmetic and geometric. But again, we're talking about series that are not arithmetic or geometric today. So those formulas don't apply. We've got to kind of look at these in a little more general fashion. So here the first term is 1. The second term is 1/2. The third term is 1/3. The fourth term is 1/4. Now all of those have 1 on top. So our AN for this one is also going to have a 1 on top. Now, what number's on the bottom? Well, there's a 1 on the bottom of this, there's a 2 on the bottom of this, and a 3 here, and a 4 here. Well, all those are equal to these numbers that are n. So the 100th term, for example, is going to be 1/100. On the bottom is just going to be n every time. So our AN is 1/n for this. Now, to use this test, we have to find the limit as n goes to infinity. So the limit as n goes to infinity of 1/n is, now you got to use this limit stuff that we talked about the other day. The highest power of n is bigger on the bottom, so this limit is 0. Now, if it's not 0, there is no sum. We're not saying anything yet about the situation where it is 0. So there may be a sum. There may not be. Again, we're not addressing that particular issue right now. Okay? We will talk about that more later. For now, we're just going to say, you know what, maybe it's got a sum, maybe it doesn't, I'm not sure, because this limit is 0. Let's take a look at this next one. Here, the first term is 1/2. This term, the second term is 2/3. Third term is 3/4. Fourth one is 4/5. So our AN for this one, so on top, it seems like we always have n squared, right? In the second term, we got 2², third term, 3², fourth term, 4². Looks like we got n squared on top. Now, what about the bottom? Well, oh, it looks like these are all 1 bigger than n, right? When n is 2, this is 3. When n is 3, this is 4. So the number on the bottom is always 1 bigger than n. So that would be n plus 1. So to figure out if this thing diverges, or not diverges, excuse me, whether we actually have a sum here, we've got to find the limit as n goes to infinity of this. N squared over n plus 1. And we figured out the other day, if the highest power of n was on top, that this limit would be, there would be no limit. For now, we're gonna say it's infinity. Okay? Now this is not 0. So since it's not 0, there is no sum for this one. And we can say that definitively. There's definitely no sum for this one. For this one, since we got 0, there might be a sum, but there might not. So when it's not arithmetic and it's not geometric, we're going to find the nth formula for the nth term. And you're going to find the limit as n goes to infinity. If you get 0, there might be a sum, there might not. We don't know how to figure that out right now. We will address that later. If you don't get 0, there is definitely no sum. And we can say that with 100% certainty.